This conference will now be recorded.
Three, one more minute. Good evening, participants. We will have the topic pointers. This is little critical session as we are dealing with the memory of data. Okay, since everything will be processed on memory, and the memory address is critical. It is by analogy we can compare this with a book. In a book, we have topic and topic description, and to reach the topic we have a page number. Similarly, here when we come to the pointers, here too we have uh, 1 minute. Here also we will be having a we say memory. We have three things in that. That is, we can say memory itself, okay, where data is stored, and title for the data, or we can say it as memory itself. and say memory title or name, and then memory as address. Here, this is this corresponds to page number, this corresponds to topic, this corresponds to the description. Okay, and so when we access, we all we need to access is the description of a topic, and so we can address it by topic, or otherwise we can address it by page number. Internally internally page number will be utilized for any compiler to access the description, since it gives a direct representation of the description. Even if it is a topic is for our understanding. Okay, so topic is only an heading. So to access the description, page number plays a critical role, and so to access the data, memory address plays a critical role. So this is what we are going to study about it now. And so when we need to declare the data type of any variable beforehand. That is how we do. For example, int a, we declare it. Okay, why we are declaring it as int a means, that is what it is internally defining is that a is a integer type. What does it mean that it is an integer type? It internally means that how much data memory has to be allocated. Data memory to be allocated means what is the storage required for the data which can be named as A. That is how much of storage the compiler should allocate for that variable. Okay. For example, we will take it as 2 bytes for integer memory. For turbo C++, compilers takes 2 bytes. Okay, if but otherwise generally if you say, if it is you are using a 32-bit processor, then 32-bit size will be utilized. Here 2 bytes means bit 16-bit. Okay, if you are using 64-bit processor, then 64-bit will be utilized. Okay, and so 2 bytes of data will be allocated in the memory, starting from where? From any memory address. For example, if the memory address is said to be 30,000, then plus 2 bytes of memory will be allocated. That is, the next storage will be 3002. If a variable b is also available, then for if A is holding at an address of 30,000, then B will be stored at 30,002. This is an hypothetical. This is only for our reference of discussion. Okay. So at A is equal to 30,000. 1 minute. 30,000, 2 bytes of memory will be stored. And so now you see, whatever it could be a data, only when we initialize the variable data, actual the memory will be allocated. Till that time it will be as the memory will not be allocated. Since for an unallocated memory, the data stored will be arbitrary. Okay. So when A is initialized as 10, this is the data, this information which we require. This is address and this is the index or variable or topic. Okay. So these three sets are the valid information of a memory. That is, if we are accessing a memory, then these three informations are only available in that. That is the variable name and then address and the data. Finally, we are going to pull out the data from that address. Okay, and so we can refer the memory as variable name or otherwise with the address also. Okay, so when we are referring the address of a variable, okay, that is indirectly we are saying an address of a value 10. It could be, we can say that it's an address of a variable. I'm repeating, could be an address of a variable or a value. Finally, we are interested in value, and so we will be using this jargon only, address of a value. Okay, that is what our topic of discussion is, nothing but pointer. And so pointer is nothing but pointing to the address of a value. So whenever we say pointer, it indicates the address of a memory, that is address of a value. And so when int this statement is executed, yeah, 2 bytes of memory will be allocated for A. When the statement is executed, 2 bytes of memory will be allocated for A. And so when we need to point, when we are speaking about the address of the value at A, then what is that we are directing to indicate? That we are going to indicate that address with a pointer. So how to indicate that? Yeah, we are going to use the address to the system. And so we are going to have that indicate the address of the A with one more variable. Since we are indicating now A with a, so we have to use pointer with integer type. And so this asterisk symbol is meant as address of value. So I will say B. Okay. Okay. So this asterisk symbol will be address, can be called as address of value or value at address. So we are interested now in the address of A. Okay, and so A is the integer variable and we are interested in the address of the A. And so when we need to identify the address of A, that is when we need to also, then we need to store that address. Okay, and so then we are pointing to the address of A, then we are storing at a one more memory, say B. So B will hold the address of B is 2, okay, for this case, but it will hold the address of A. Now you see A is at address of 30,000 is holding data 10. Now B is at address of the 30,002 will hold the address of A. This is data here. This is index. So the data at pointer B, that is value at address, will be 30,000. So this B will indirectly point to the value of A. That is the value which is stored at this address, that is B, will is nothing but the address of A, which is nothing indirectly pointing to the value of A. So now we will do there is any doubt till now, or if the topic is not clear? If you can confirm, then we can move forward. If you can tell that whether it is clear or not clear, then we'll accordingly take corrective actions or next step will go. So when the value when the address of A will be stored at B is when we execute B is equal to ampersand of A. When the compiler sees this is nothing but this ampersand symbol mentions nothing but it is nothing but indicating the address of A. So any pointer which is variable which is store any variable which is storing the address of one another memory has to be declared with an asterisk symbol, and what is the destination's memory we are indicating, we have to indicate it here. That is, what is the address finally this memory is pointing, that data we should indicate, so that the compiler can understand what is the data size of A, that is whether it is a 2 bytes of memory or if it is a float 4 bytes of memory, it can understand. For example, if A is float, then the case will be like this: 4 bytes of memory, 4. Since the 4 bytes of memory is required for float, B is equal to. So shall we see this with an example? If it is not clear, kindly confirm so that the further topics will be with respect to pointers only, and it is critical if you are interested in programming like Python program and all, also pointers plays a crucial role. Is that shall we move forward? Okay. Shall we move forward? Can anybody confirm? Hello? Anybody can confirm? Okay. I'll simplify in one more format. So A is a variable, 10 is the data in that memory, 30,000 is the address. In practice, it could be any address. This is how it is. So when we point, when we speaking about a pointer, this is a pointer variable. This is a decimal variable. Okay, this is a data type of integer data type, and this is a pointer data type. B is a pointer data type. Okay, so similarly you can go for one more also, one more declaration like C, and this can point to 3000, 30,002, and This memory can be at anything, 10,000. So when it comes to this case, then we have to tell the compiler like it is int a comma star b comma star star c. This is the indication. This is an integer data. This is a integer pointer to pointing. This is an in pointer which is pointing to the integer data, and C is a pointer which is pointing to a one more pointer which is pointing to a integer data, which in turn points to integer data. Like similarly, you can extend, but usually this will be sufficient. Okay, so we'll go for a simple example. We will see what is the this practically how it is. That int I int a star b, otherwise we will read the address. Enter. So three things we were discussing. So value, address, and variable name. Variable name, it's in our control, and so we will not bother. So we will go for value and address. We will access directly the value. Okay? We will access the address of the value. How it will be addressed? It will be addressed by the ampersand symbol. So ampersand symbol gives the value of address of the value. So we will point through now address value access using address, that is value at address. So destination is also integer, and so we are using D here, and then start of ampersand A. Since address of A is nothing but the pointer of A, that is ampersand of A is nothing but the pointer of A, that is the address of A. And so this asterisk symbol indicates the value at the address of A. And so this this asterisk symbol access the value at the address of A. Okay, we will add new line indications. Since we are used to integer, the program and see. So we go for on IO. Value accessed directly is 10. Address of value is -12. And value accessed directly using value address is 10. Okay, we will run one more time. We see what is the, so it is having same address now. We'll compile one more time. Same. Okay. Now we'll see for float. Actually, address of value, since the value is address will be a integer value, and so to display that we are using D. Okay, that is here. Address will not be a float, while the memory which that address pointing to that will be a float. And so while declarations we have to be careful. While when we are directly printing it, it's okay. So we'll go for one more program, how we'll be using it, the pointers. So this is clear now. Shall we move forward? If you want, we will go for one more extension. Like we have seen, similarly, print the same thing. So finally, we are accessing the value only. So to reach values, we have used up to two pointers. And so two more data memory was also utilized, which was storing the respective addresses of the previous memory location, which needs to be pointed. Okay. So where these pointers are used, like in our previous discussions of functions, we are able to return only one value. When we are want to return more than one value, then pointers can be utilized. Suppose if, and one more thing is, when we need to manipulate on the data directly, then pointers are also utilized. Like we will see the previous program. I think whether it is here function is created. So when we create a function, the data is very local to the function. Here if you see this data fact is local within the function. When this function's closing brace is executed, then this data is also, this memory is also, memory linked to this memory is also deleted. And so when we need to access directly the data, like these variables are also very local to the main function. This cannot be accessed by the factorial functions. So when we need access the variables directly across the functions, then address can be utilized. Since its address is a direct connecting pointing to the memory, and so when we know that address, then we can access the value at that address also directly. This is the reason why when we are giving direct access to the memory, that is why advanced programming languages like C++, C++ pointers are there, but they don't emphasis on that pointer usage. And if you see .NET and all, they have stopped oops like Java, proper oops like Java and all. They don't give access to the pointer, that is memory directly. Okay. Since somewhere if we manipulate the data, and it's very difficult to find the root cause of any problem. If unknowingly if you are manipulating data, it will be problem to find out the root cause of the problem. So we will stop at this point for today. If you have any doubt, you can ask me, so that I want you to get clear on this topic before going to the how to access return multiple data from a function, or how to access the values across the function in next session. Is that okay? Is topic was clear? Okay. I I want I request you people to execute the programs in the compiler and then see it if, before the next session. You try to execute some program, like the similar program you try to execute and see, so that it will be very useful to understand. I want you to execute the same program in the compiler and see it. Okay. Thank you. Bye.